Hey buddies, my name is Sibusiso, but you can also call me Coach Sbu. Welcome into the Maths Buddies tutorials. In this video, we're going to be going through what I would like to call March exam preparations. Basically, March exam preparation means that you're going to be going through a series of videos where I'll help you prepare for your March exams. Now, these videos are going to be containing topics that you might have covered into your class, right, or at your school. Now in this video, we are specifically focusing on a grade 12 content. So and we're also going to be going through the first topic, which is what we call trigonometry. So without wasting any further time, let us jump right into that topic, right? Now here we are given a question 2 that we would like to solve here. So let's go ahead and solve this question so I can help you understand how you can actually simplify all these type of questions or answer all these type of questions. Now the first question here that we are given, it is a 2.1 question, and we are asked to simplify cos negative theta times tan 180 minus theta times cos 90 minus theta all divided by sine 180 minus theta multiplied by sine 540 plus theta. Alright, now what is the first thing that you do when you always simplify with this? Now the very first thing to do is to check out your negative angles and the angles that are above 360. Now the idea here is that if you have an angle that is negative, you need to add 360 there. Now in this case here, we do have negative theta, which means here we're going to write it as plus 360. Now what about this one here? Another one here is above 360, right? If we have an angle that is above 360, it means we need to subtract 360 there. Now what happens when we do this? Now this means now the second thing that you're going to do is you're going to update the expression, right? And then have the 360 minus theta there. And then here we have tan 180 minus theta times cos 90 minus theta over sine 180 minus theta times now 540 minus 360, that gives me 180 plus theta. Now I am aware that another way that you could have easily done the negative one, it is to just focus on it as being a negative angle on the fourth quadrant and then turn that into a positive cos, right? So there are many ways, but we're just going to be focusing on this one at the moment. Then from here, we're going to be basically applying, next step is to apply basically your reduction angles. Now the reduction angles, sometimes people, they tend to actually struggle into memorizing the quadrants in which they belong, right? Now the easy way to do that, it is by actually doing this, right? Now we know that the first value, right, that is the reduction, starts with 360, right? And then in the next one starts with 180, right? First and the second quadrant, right? So what you do is that you're gonna just write 180 below that and then 360 below that. So the 360 needs to be underneath 360, 180 needs to be underneath 180. Then now after that, right, in order for you to know whether it's a plus theta or negative theta, it is to simply start with the first quadrant by adding theta there, right? So now what you're going to do here, if you add theta there, it means now you're gonna keep alternating the signs, right? See there, I'm just alternating the signs. Then that is how I find all my reductions. Now here, I know that all of them are positive, sine is positive there, tan is positive there, and cos is positive there. So I'm gonna so now we're gonna go ahead and apply these reductions. So when we do that, we see that 360 in the fourth quadrant, cos is positive there, so it means I'm gonna have cos theta. And then now here 180 minus is in the second quadrant, but 10 is negative there, so I'm gonna have a negative 10 theta. Now what is cos 90 minus theta? Now cos 90 minus theta is what we call a cofunction. Now let's go ahead and talk about cofunctions. Now with the cofunctions, the same is true, right? But then now with this one, it is like this. Here at the top you have 90, and then at the bottom you have 270. Now instead of doing top and bottom, you're gonna do right left. So which means here it's gonna be 90, right left, here it's gonna be 270. Now on the reductions, we started with positive, In the on the cofunctions, however, we're going to be starting with a negative theta. So it means now here we're going to have negative theta, but then keep alternating with our sign there. So you can see there minus theta plus theta. Now this is an easy way to help you understand these cofunctions. Now another thing that you need to remember about cofunctions is that when you have a trig ratio of sine, you change it to cos, right? And vice versa. If you have cos, you change it to sine. All right, so now here we have cos 90 minus theta. 90 minus theta belongs in the first quadrant. Cos is positive there, but then cos changes into sine theta. And then now at the bottom, 180 minus in the second quadrant, sine is what there? Sine is positive. So I'll have sine theta there. Sine 180 plus theta. 180 plus theta is in the third quadrant. Sine is negative there. So I'll have negative sine theta. Then now from here, I can see that this sine theta can cancel with that. And then I can multiply this cos theta with that negative tan theta. And that will give me negative cos theta times tan theta, right? Then now over here, I'm going to be left with negative sine theta. Now here, tan theta, it is also an identity, right? So we can then write this as sine theta over cos theta over negative sine theta. Now here, you can see that this cos theta will cancel with that. And then we're going to be left with negative sine theta over negative sine theta. Now negative sine theta, they cancel both each other, and then the answer becomes 1, right? So that is the first one. Then now let's go ahead and look into the second one. Now the second one is saying that we're given that cos A minus B is equal to cos A times cos B plus sine A times sine B. Now we need to prove that sine A plus B is equal to sine A cos B plus cos A sine B. So basically we need to prove this using that one. Now how do we do that? Now whenever we're proving compound angles, always use a co-ratio. Now here we want to prove which one? We want to prove A plus B. So it means we want to write sine A plus B as a co-ratio. Now when you write it as a co-function, it becomes cos 90 minus A plus B. Now here we can then simplify this as 90 minus A minus B, right? Then now from here, what we then do is we need to actually make it look like that, right? So how we're going to do it is that we're going to take the first two terms there. So I'm going to use a different color for that. The 90 minus A, we're going to put it into a bracket to show that it is one angle. And then from there, I'm going to put a minus, and then B is going to be another angle. So I'm going to write it as B. So by having it like that, it then looks similar to that one, right? So because of that, it then means now I'll just expand according to that one. So this is going to be cos 90 minus A times cos B plus sine 90 minus A times sine B. Now cos 90 minus A, it is a co-function belonging in the first quadrant, and then now which means cos A is positive, so this becomes sine A. And then I add cos B plus, and then here I have sine 90 minus A also in the first quadrant, and then sine becomes cos A, then times sine B. Now as you can see here, this becomes the value that is there on that question that we're given there, right? Now let's go ahead and go into the next one. Now into the next one here, we are given that 5 sine A plus 3 is equal to 0, and A is an element of 0 to 180, right? Now this is trigonometry in basically triangles, right? Now how I do this one, or the easy way to approach this one, is to always notice it by having two statements like that, right? Now this end, it tells you that you're going to be having two conditions here. Now let's start with the first condition. Now the first condition here, you will always be given 5 cos A plus 3 equals to 0. So here you will be given a trig ratio to solve. Now here, if I solve this trig ratio, I can see that I can have cos A being minus 3, and then cos A will be minus 3 over 5. So here I divided both sides. Now, what do we then do with this information? So basically here you will then ask yourself, right, that what is cost ratio, right? So we know that the ratio of cost, right, it is cos, it is adjacent over adjacent is x over hypotenuse is r. So this tells me that here, this ratio here, I have my adjacent at the top and then my hypotenuse at the bottom, right? Now, what's the second thing that it tells me? It tells me here that this cost ratio here, this cost here, it is negative. Now, according to my Cartesian plane, which quadrants do I have cost being negative? So now I know that cost becomes negative in the second quadrant and the third quadrant. So now here, what are we doing? We're trying to locate a triangle here. So this triangle, it can either be, or it is either in the second quadrant and the third quadrant. Now to understand it precisely in which quadrant it is located, it means now I'll have to go and look into the second statement. Now the second statement, it says that the angle of this triangle, that is between 0 and 180. Now which quadrants that are between 0 and 180? Now as you all know, those quadrants are going to be quadrant 1 and quadrant 2. Now here we see that there's going to be what? An overlap. Now as you can see here, we have an overlap here, quadrant 2 and quadrant 2 here. So let me just fix that and write it as 2. Now what does this mean? So this means now here we have a triangle that we're going to be using to answer the questions, and then it is located into the second quadrant. So let me just draw the Cartesian plane like that, and then draw our right angle triangle. Now the angle here, I can put it there, it is totally fine. Now here, remember we were told that cos A, it is minus 3 over 5. Now here we're gonna have minus 3 as adjacent and then 5 as our hypotenuse, which means now we need to find the value for y. Now to find the value for y, I'm going to be applying Pythagoras theorem. Now Pythagoras theorem states that x squared plus y squared is equals to r squared. Now here I want to solve for y squared, so this is going to be that, and then now here, which means if I put square root both sides, right, then the value for y is going to be plus minus the square root of r squared minus x squared, right? So now it means now I'll just substitute my values right there. R, it is 5 squared minus, I have a minus 3 squared. So now I'll take out my calculator, and then when I take out my calculator, I have square root 5 squared minus 3 squared. Now what do I get there? I get 4. So it means the value for y here, it is plus minus 4. Now because of my y, it is above the x-axis, it means the value that I'll take there, it is y equals to 4. And now I'll take that value and substitute it there. So let me put the 4 there. Then from here, we'll then answer our question, right? Now, our question here, I forgot to write the numbering here, 2.3.1, it wanted us to solve for what? For sine A. So this therefore means that the value for sine A, we can see that it is the opposite, which is 4, or y, over the hypotenuse, which is r. Now the value there, it is 4 over 5, and that is the value for sine A. Now the second question, 2.3.2, it wants us to solve sine 2a. Now sine 2a, this is a double angle. So now we know that this is 2 sine a times cos a, right? Now this is going to be 2 into, we know that sine a is 4 over 5, multiply, now cos a, according to the instruction there, it was minus 3 over 5. So I'm going to have minus 3 over 5, right? Now here they say without the use of a calculator, so which means we'll have to multiply on our own. Now 2 times 4, it is 8. 8 times minus 3, it is minus 24. And 5 times 5, it is 25. And that is the value for sine 2a, and then that is how we get into our value for the 2.3 questions. Now the 2.4, let's go to 2.4. 2.4 says we need to prove that 10x is equals to 1 minus cos 2x minus sin x, all divided by sine 2x minus cos x. Alright, now in order for us to do this, we'll first, this is when we're proving identities, right? So in order for you to prove identities, you need to first take the equation or the expression that still needs to be simplified. Now according to this, we see that the right hand side, it is the one that we need to simplify. Now how do we simplify this? Now looking at the nature of this, you have to understand this every time when you're doing simplification, right? The nature of an expression matters, especially in trigonometry. Now here, this is a fraction. That's the nature of this expression. Now fractions, we know that they always like to have one term at the top and one term at the bottom. Now here you can see that at the top you have 3 terms, but at the bottom you have 2 terms. So which means now in order for you to achieve the state of a fraction itself, you have to factorize both sides, right? But then now how do we then factorize here? So the easy way to approach this is to always look for double angles. Now the first double angle that you always need to start with, it is the double angle for sine. Why are we starting with the double angle for sine? Because the double angle for sine has one equation. So it is just 2 sine x times cos x, right? So this helps us to understand what's going to be happening here. So now I see that here at the bottom, I can factorize by taking out the common factor of cos x, right? Now, what about at the top? Now, at the top here, I have 3 terms, right? Then I have cos 2x, and then cos 2x is a double angle, and then it has 3 formulas, right? So now, in order for me to get the right formula, I must look at the top, a trig ratio that is there, like a basic trig ratio. Now, by basic, I like to call basic sine x, cos x, tan x, right? Because those are the original trig ratios, right? Or when you talk about functions, we call them the mother functions, right? So that's how we actually discover them as the basic one. So now here we have this double angle for cos, so which means we need to change it according to a double angle or to a solution that has only sine. So this means now here at the top, we are going to change cos 2x into 1 minus 2 sine squared x. Now the reason for that is because we have this sign that is guiding us there, right? So here we have then minus sine x, and then here at the bottom we have our common factor, if you remember, which is cos x, and then we left with 2 sine x minus 1. Now at the top we're going to have 1 minus 1, because we're going to multiply this negative with that to give it minus 1, then we multiply it again there. It's going to give us a plus 2 sine squared x minus sine x, and then here this will be over cos x into 2 sine x minus 1. So this will cancel out, and then I'm going to be left with 2 sine squared x minus sine x over cos x into 2 sine x minus 1. Then I'll take out the common factor there, which is sine x, and then I'll be left with 2 sine x minus 1 over cos x into 2 sine x minus 1. And then this will cancel with that, and then my value is going to be sine x over cos x. Now what is sine x over cos x? I know that that is 10x, and this is basically what is on my left hand side. So the left hand side now, it is the same as the right hand side. And that is how we finish the first part of our trigonometry. So let's go ahead and go into the second part. Now the second part of our trigonometry, it is going to be basically the trig functions, right? Now in the trig functions here, we have our very first question there, which is something that we didn't cover in our previous question, which is the general solution. So let's first determine that general solution. Now, how do you define a general solution? Now, the idea of a general solution is to solve a trig ratio. So let's go ahead and see what we have here. So now here we are given 4 sine x plus 2 cos 2x equals to 2. So our aim here is to solve for the value of x, right? Now, how do we do that when it comes to trigonometry? So firstly, we need to solve for this and then take out one basic trig ratio and then apply the rules of the general solution. Now here, I have cos 2x. And then remember, like I said in the previous video, when you have a double angle for cos, always look for a basic trig ratio. Here I have what? I have sine x, right? So which means now here, what I'm going to do first thing is to change cos 2x into 1 minus 2 sine squared x, right? Now equals to 2. So this will then help me to actually have something like that, right? That has sine both sides. So I'll take this 2 across. So when I bring this 2 to the side, let's see, squared x minus 2 equals to 0. You can see this cancels with that. And then now I have 4 sine x minus 4 sine squared x equals to 0. So I'll divide by 4 like that. Then I'll have sine x minus sine squared x equals to 0. Then I can see now here I can factorize by taking out a common factor, which is sine x. And then this will leave me with 1 minus sine x being equals to 0. So what does this mean? So this means now here sine x is 0 or 1 minus sine x is 0. Basically here it means 1 is going to be sine x, or you can just write it as sine x being 1. Now, this thing here, it matters a lot when it comes to general solution, right? It's because here, in the sense that how it works is that when you have it this way, it means now here, you have to first apply general solution from this trig ratio and do the same thing on that trig ratio. So let's go ahead and start with this one. Now here, we're given that sine x is equal to 0. So it means now here, the value 0 is a value that is neutral. So we cannot say for sure which quadrant we're going to be focusing on. So because of that, we're going to then go through quadrant 1 where sine is positive, and also try another quadrant where sine is negative. So now the first thing is to say which quadrants we're going to be doing the general solution. So for this video, we're going to be choosing quadrant 1 and quadrant 3. Alright, so next thing is to find a reference angle. Alright, so reference angle, it is going to be sine inverse of that value that we have there, so it is 0. So now here, when you press on our calculator, this gives us 0. Then now from there, we're going to go straight into our general solution. Now I like to give out a formula for a general solution because people, they tend to make mistakes when they get to a general solution. Now firstly, when you look into the equation like this one, right, you need to understand how this equation is structured, right? So this equation, this angle that you see here, right, whatever angle it is, because sometimes it cannot be x, it can be 5x or whatever value it is. So this angle, I like to call it a general solution. So I'm going to write it as a gen sol. And the reason for that is because it is what you take when you actually go into your general solution. And then now here, this value here, I like to call it a reference angle because it is the angle that you use when you're calculating a reference angle. Sometimes they will get to be a sine there, right? So this sine, it helps us to locate quadrants. Right? So now here, when you do a general solution, the formula that you can use, which is much more easy, it is this one. So basically for sine, it is the general solution that is equals to, right, the reduction formula, right, reduction formula plus the period for sine, it is going to be 360k, where k is an element of integers, right? Now, how we're going to be doing this is like this now. Now here, we're first going to be focusing on the first quadrant, right? We know that the reduction formula there is just a reference angle. So which means now the general solution for that will be x as a general solution equals to reference angle, which is 0, plus 360k, where k is an element of integers, right? Now what about the third quadrant? The third quadrant, we know that its reduction, it is 180 plus reference angle. So it means now here for this one, the general solution is going to be x equals to 180 plus 0, right, which is just 180, plus 360k, where k is an element of integers. So that is how we basically do the general solution. Now let's go ahead and look into the second equation, because remember we had two equations. Now when we look into the second equation, right, you will notice that now we have, let me go back there, we have sine x equals to 1, right? So the second equation, it is sine x equals to 1. So let me use this color. Sine x equals to 1. Now here again, let me just write it as positive 1. Here again, we're going to be doing the same thing. Here, x is going to be a general solution. This positive sign, it then means now we're going to be looking only into the quadrants where sign is positive. And in this case, it's going to be quadrant 1 and quadrant 2. And then the reference angle here, we're going to be using that value for 1, right? So now which means now for our reference angle, we will say is going to be sine inverse of 1. Now press this on your calculator and then you're going to be getting 90, right? And then we'll see now on our general solution. Therefore, first quadrant, we know the reference angle or the reduction angle. Reduction formula, it is reference angle. So which means now x, which is the general solution, is equals to 90, which is a reference angle, plus 360k, where k is an element of integers. And then now the second quadrant, it has 180 minus reference angle. So we're going to say x equals to 180 minus 90 plus 360k, where k is an element of integers. And now from here, x becomes 90 plus 360k. So that is basically how we go about with the general solution. Alright, so now let's go ahead and look into the second question. And the second question here, we are given that the graph of g of x is equals to minus 2 cos 2x for x is an element of minus 180 to 180, including minus 180 and 180. Alright, now the first question says now we need to draw the graph of f of x is equals to 2 sine x minus 1 for x is an element of minus 180 to 180 on the same set of x's with g. Alright, so now here basically we are being asked to sketch this graph here, 2 sine x minus 1. So the domain or the restriction there, it is still the same as that one. Now whenever we sketching, we need to understand our graph, how it looks like, right? So now here we always start with what? With the period, right? So the period here, it is always 360 divided by the value that's going to be next to x. Now in this case it's going to be 1, so it means it's going to be 360. So it means now we understand that we're expecting our full wave between 0 and 360. All right, then now from here we're going to be looking for a maximum, right, and a minimum. All right, now according to the formulas, the formula that we use for our maximum, it is the value, which is the positive amplitude, right, the positive amplitude minus the value for q, right, and then, or we can just say plus q, like that, and then here it's going to be the negative amplitude plus q. Yeah, so these are the formulas that we can use to help us calculate that. All right, now here the positive value for a here, it is going to be that 2, right, and then the value for q, it is going to be minus 1. So which means now our maximum value here is 1, and then from here it's going to have minus 2 minus 1, which is going to be minus 3, right? So those are the maximum and our minimum. Now it is also very important to take note of this value here, or the sign of this value here. You can see that this is positive. Now because of it is positive, let me just do this. Okay, let me use a different color because I want to explain something there. So because of this part, it is positive. It means your graph, when you sketch it, it will start at 0 to like that, or basically to have this sketch, right? Or a sketch which is going to be like that, or structure like that. Now, basically, the idea of this structure is that it goes to maximum first because it is positive, right? Now, how do we actually then plot this graph? So basically, to plot this graph, it is actually by using the calculator. So now here I've created I took basically the copy of this, and then I just made it bigger there, and then now what I'm going to do is I'm going to go into our calculator and show you how you can sketch this. Now, how you basically sketch this, it is to always sketch right the graph that you're given there, right? So here we're gonna press shift mode on the calculator. Then now this calculator, most of the time people they get confused with this one, right? So with this one you need to look for the option that says table, right? So the other calculators, they don't have a lot of options like that, but they do have the option that says table. So look at the number next to that table, then press that one. So you should get something written as f of x, right? So now the formula, go back to the formula, it is 2 sine x minus 1, right? So it means now here we're just going to press 2 sine. Now to press this, there's an x there on that bracket. To press it, you're going to press alpha, then you're going to say x, then you're going to close that, then you're going to say minus 1. Let me just check there. Okay. Then you're going to say equal. And then you're going to ask you for t of x. So for t of x, you're not going to do anything. So you're just going to press equal sign. So it's going to say start. Now the start, basically it is the interval here that we're given. So the start here, it is going to be minus 180. And then the end here is going to be 180. Now there's this part where it says step. Now when we're dealing with trigonometry, steps are calculated based upon the period that we have, right? So how do we then calculate the steps, right? So in order for you to calculate the step, basically what you do is you take the period and then you divide it by 4. In this case here, we're getting 90, right? And then from there, you will then say 90. There you go. All right. So now what is happening here? So basically, it's helping you by telling you that when the x value is minus 180, its y value is going to be minus 1. So now basically what we're going to do is we're going to go back into our equation, and then we're going to basically plot that. So here we can see that when it's minus 180, it is minus 1. So there's minus 180 minus 1. So I'm going to highlight it there. And then from there, it says when it's minus 90, it is minus 3. So that will be there. And then from here, when it's 0, it is minus 1. So that will be here. And then when it is 90, it will be 1. 90, it will be 1. So that is definitely there. And then when it is 180, it will be minus 1. So 180, it will be minus 1. And then from here, you will just join your graph. Now remember, when you're joining it, it is always easy for you to start where you have your curve there, right? So for me, I always like to start where we know that normally when you sketch it, we sketch it from 0 to the right. Yeah? So it means now here, I know that this graph, it goes like so, right? And then like so, right? And then from there to go like so. And then like so. So now here, just try by all means to sketch it. There we go. So that is basically how it looks like. Let me try and fix this one. I don't like how it looks like. I like when it's more heavy. Alright, let me try and fix the last one. There we go. So that is basically how it would look like, our sketch here, and that is how you're going to be sketching our value here. So let me go ahead now and do the next question. So the next question here, it is 3.2.2, then it's asking for which values of x is g of x strictly decreasing, right? Now it says now this is in the interval between minus 180 and 0, right? So to strictly decrease, what does it mean? Basically, to strictly decrease, it means now that your values are actually dropping, right? So now as you can see here, the graph here, it is going up, then from here it is going down, it's going up, then it is going down. But then now our forecast, it is just between minus 180 and 0. Now you can see that our graph, it is strictly dropping when the x values are between minus 90 and 0. And so basically the answer there, you just say your x is in between. So these two inequality signs, when you're pointing both of them to the left, it means in between, right? So in between what? Minus 90 and 0, and that's how we get our value. And then finally 3.2.3. so here it is asking another question now. So it's saying here, for which values of x is f of x times 30, is f of x plus 30 minus g of x plus 30 equals to 0, right? So basically what this is asking is very simple, right? So now here they're saying that they want to find the values of x where the equation of f minus the equation of g plus 30 equals to 0. Now, when you're dealing with questions like that, such things, they don't actually make sense, right? So here they just did it like that to confuse you, right? So the first thing that you need to understand here is that they're not asking you to subtract two values equals to 0. So, but basically they're asking you to find the values where f of x plus 30 is equals to g of x plus 30, right? Now, this 30 here is also another confusion here, right? Another confusion in the sense that here these values are actually shifted 30 units to the left, right? But then now when they shifted 30 units to the left, it becomes much more difficult for you to understand what are the x values and all of that, right? Now, in order for you to get those x values, the first thing that you must then do is to ask yourself, right, when. So this is what you need to do. Let me write it. Ask yourself, what were the values of x, right, when f of x was equals to g of x? Because whatever that happened, it all started right here, right? When we shifted the values to the left, it all started there. So now, which means now what we need to do is we need to start by asking ourselves before what was happening, right? Now, before we can see that we can easily take that from our equation, right? So before, when the equations were equal, we know that they were equal where here, which is here, this is when x was equals to minus 180, and then here, this is when x was equals to 0, and then there, this is when x was equals to 90, and then there, which was when x was equals to 180, right? Then from there, what we're going to do then, we're going to shift these values 30 units to the left. All right, so now here, what are we going to do? So here, basically, we're going to say, now we see from the diagram that this was true when x was equals to minus 180, when x was equals to 0, when x was equals to 90, and when x was equals to 180. All right, so now to answer the question that we asked, therefore, to get the values where the graphs were then shifted to the left by 30 units, what we're going to do is we're going to just take this value that we have there, shift it to the left by 30 units. So now here we can see that when we have minus 180, if we subtract 30 there, it gives us minus 210, right? So it means now here we have x as minus 210, and then there we have x as minus 30, and another one we have x as 60, and another one we have x as 150, right? But then remember, the question, it said that we need to only take the x values that are in between minus 180 and 0. And then now here, minus 210, it is not in between minus 180. and 0. So therefore our final answer will then be minus 30 and 60 and 150, and that is how we basically answer this question. Now I know this video was very long, and this was actually to help you to understand some of the questions so that you can be able to prepare for the exam. Now luckily I have also have an offer, that is, if you want to do more of these questions and you have questions that you would like to ask, right? I am running a promotion, or I'm going to be running a math prep or math exam preparation course, where I'm going to be going through the preparation of all the topics that you're going to be covering, right? So let me first take you through the post that I'm going to be writing and explaining to you how it all works, right? So basically the course or the math exam lessons that I'm going to be running through are going to be done online. So basically what is happening here is that we're going to be preparing for our March exam, well, basically our March exams. Now how it works is that it's going to be starting on the 4th of March, and each session is going to be done at 6 p.m., right, which is late after you come back at school, right? And then it's going to be running from Monday to Friday, and then at 6 p.m. each day, and then all classes are going to be done online. Now to register, all you have to do is to basically type this link on your cell phone, and it will take you through into the registration process, and it will help you register. And also, in order for you to be part of this sessions, you will have to make a once-off payment of how much? Of 300 South African rands. It's going to be offering you 10 lessons. Now these are strictly the topics that we know that you might have covered during the first term. So some of those topics will be equations and inequalities, exponents, trigonometry, Euclidean geometry, and then for grade 12 it will be trigonometry, Euclidean geometry, sequence and series, and functions and inverses, right? Now in all those topics you don't have to actually attend all of them, but you can just attend the ones where you know that you've actually covered these type of topics into your school, right? That way you can only practice for that. And that's it for this video, and I'm gonna see you on to the next one, where I share some of the topics that we're gonna be covering into this math March exam lessons, and I'm gonna see you into that one.